Lesson 50 gives us our first trig equations to solve. Up to now, we've just been simplifying things. Now we're going to have a whole equation, something equals something, and we're going to have some trig stuff somewhere in there that we need to solve. So what we're going to look at today will be equations like this. They may have sine, cosine, or tangent in there, or they may have our reciprocal trig functions in there. We'll actually do this example in a few minutes, but I'm going to start with one that's a little bit easier and start with, in general, what does it mean to solve things? So if I say solve an equation, what does that mean your job is? If you have something like 5x equals -4, solve that, Allie. So to find x, and what would it be for this one? So you want to find the x that makes it true, and in this case, -4/5 would make that a true equation. What if I gave you this one? So x squared is 25, and if I said x is -5, have I solved it? Why not, Kane? Okay, so solving doesn't mean find one answer that makes it true. It means find all of the answers that make it true. So in this case, we'd have to say the two answers, positive and -5. Can I have more than two answers? Sure. What if I had one like this? How many answers here? Everybody hold up fingers. So that one would have three answers, and our job would be to list all of them, which would be 3, -1, and 8. So it means write down every single possible value for the variable that makes the equation true. So now we move to trig ones. So write down every single angle that has a cosine of √3/2. So cosine, is that my x's or my y's? Cosine is the x's, so that means from the y-axis I'm moving to the right. So that means these two, first and fourth quadrant. √3/2 is getting pretty far over here, so it's those two places on the unit circle. So I could say, oh, that means 30 degrees, that means 330 degrees, that means 390 degrees, that means 360, 690 degrees, if I did that right. And I can keep going around and around and around and around. I could say -30 degrees. I could say -330 degrees, -390 degrees. And I could keep going on and on and on. And I could say pi/6. And I could say 11 pi/6. And I could say 13 pi/6. And on and on and on. And I could do the negatives of those. And I still haven't listed all of them, so I haven't finished solving it. So I'm going to be at this forever and ever, and that's never going to get done, right? Because we can do radians, degrees, positive direction, negative directions, around and around and around and around. So in order to solve these, we had to have a restriction on which answers we're looking for. So whenever you are solving these kinds of problems, you will have something like this. So same equation, but now saying just the ones between 0 and 360 degrees. They could do any restriction they wanted. They could do between 0 and -360 degrees. They could do between 180 and 360 degrees. They could do radians. They could do whatever they want on it. So we just have to look at it and say, well, which ones are within that range? And for this one, since it's degrees, positive direction, once around the unit circle, we would simply say the 30 degrees and the 330 degrees, and that would be our answer. So give me thumbs up, thumbs down. How do we feel about that one? Does that make sense? Some of the trig equations will have ones you know the unit circle on, sine, cosine, and tangent. Others will be the reciprocal trig functions, like this next example. So when we have something like this and it's messier, it's got more stuff in there than what we had on the first one. First thing we want to do is to isolate whatever trig value we start with. So in this case, we want to isolate the cosecant of theta. So I'm going to subtract 2 from both sides. So root 3 cosecant theta is -2. Then I'm going to divide both sides by root 3. So cosecant of theta is -2 over root 3. Since I have not memorized a unit circle for cosecant, I need to get it to one of the circles I know. So I need to take the reciprocal of both sides. That means for the side that has the trig function that I don't know the unit circle for, I take its reciprocal, and the reciprocal of cosecant is sine. Now on the other side, to take the reciprocal, I have to turn it upside down. So negative root 3 over 2. Reciprocals just turn a fraction upside down. It's when we're doing perpendicular lines that we need the negative reciprocal, that we turn it upside down and change the sign. This, we're not looking for the negative reciprocal, we're just looking for the reciprocal. All we do is turn it upside down, it stays negative, or on another problem, if it's positive, it stays positive. So now I can think about the unit circle. Sine, everybody, x's or y's? Y's. So now I know that I need to be below the unit circle, or below the x-axis. Quadrants 3 and 4 are where my y's are negative, where I've gone down from the origin. And so I need to be most of the way down. So I'm looking for these 2 positions on the unit circle. My restriction is degrees, not radians. Positive direction, 1 time around the unit circle. So Kate, how many degrees would I be at if I am right here? And what about if I am over here, Jack? So that one would be 300. So those are my 2 answers, and I say theta is 240 degrees, 300 degrees, and be sure you remember your degree signs on these to show that it's definitely not radians. Question from anybody there? Okay, next one. Okay, again, we're going to isolate the trig function. So this time we're going to isolate the secant of theta. So 3 secant theta is -3 root 2. Divide both sides by 3. And the secant is minus root 2. Have not memorized a secant unit circle, so we need to take reciprocals of both sides. What is the reciprocal of secant, everybody? So cosine, nothing with a 1 over on this, just secant and cosine are reciprocals. The other side I need to flip upside down, so I need to think about that with a denominator of 1 so I can do it right. Stays negative. 1 over root 2, rationalize the denominator, and I have negative root 2 over 2. So now I think about my cosine circle. I'm back to my x's. X's are negative if I go to the left of the origin, so quadrants 2 and 3. And these are the ones, the root 2 over 2's, that are right smack in the middle of those 2 quadrants. So Evelyn, what would be my degrees here in the second quadrant? And what about degrees here in the third quadrant? Olivia? It is indeed 225. So those are our answers. Theta is 135 degrees or 225 degrees. And we have that. Final example today, I want you guys to do on your own. So isolate tangent. Is tangent one you know a unit circle for? So you don't need to take reciprocals. Just isolate tangent and write down the degrees that would make that true. that one. So everybody have tangent is -1. So first thing, which quadrants is tangent going to be negative? So where do we get negative ones, Macy? So 2 and 4, and tangent is ±1 when sine and cosine are equal, sine over cosine, right at the 45s. So what are our degrees? Lily, how many degrees here in the second quadrant? We're right smack in the middle. So 90 plus 45 is 135. And then what about fourth quadrant? Rhea, what do we have there? Yep. Questions from anybody on that? So they will get harder. You've heard me saying, oh, they asked for it in degrees. We're going to have ones later on where they restrict it to radians. Same process, just give your answer in radians instead of degrees. We're going to have some where we go around the unit circle more than once with the restriction that we have. We're going to have some that are messier, where instead of just theta, we do 2 theta, or we do x over 3, or something different in there. But in typical Saxon style, we'll build the skills until we get there. We're starting with pretty simple ones. But thumbs up, thumbs down, how do we feel on these so far?